Okay, now we will do tutorial 2.4. The question is 50 kVA, 2400 to 240 volt 60 hertz distribution transformer has a leakage impedance of 0.72 plus J 0.92 ohms in the high voltage winding and 0.007 plus J 0.009 ohm in the low voltage winding. At rated voltage and frequency, the impedance Z5 of the shunt branch means parallel branch. The shunt branch equal to the impedance RC and JXM in parallel. Accounting for the exciting current at the shunt branch itu is 6.32 plus J 43.7. Kenapa ohm ni? Okay, this is the value of shunt branch. This is the value of shunt branch Z5. Okay, so this is Z5, value of shunt branch. Bila ada exciting current, dia punya impedance adalah 6.32 plus J 43.7. Okay. So when viewed from the low voltage side, okay, draw the equivalent circuit referred to A, the high voltage side, and the other equivalent circuit referred to B, low voltage side. The first thing first, we are going to draw the equivalent circuit of this question. The first one is referring to the high voltage side dulu. So I just write down the information given in the question. So we have high voltage side and low voltage side of the transformer labeled by 1 at the high voltage side and 2 at the low voltage side. So this is the transformer information: 50 kVA, 2400 at the primary volt, 2400 volt at the primary side and 240 at the secondary side, and this is a 60 hertz transformer. So when it is given by the ratio of the voltage at the primary to the voltage at the secondary, which is 10 times. This is also the step down transformer. This is step down transformer. So this is step down. This is step down transformer. Given that the leakage impedances of this transformer ZL1, impedance at the leakage impedance at the primary side lah ni. Okay, 0.72 plus J 0.92. So this is at the high voltage side. Okay, and then leakage impedance at the secondary side 0.007 plus J 0.009 in low voltage side. Okay, so shunt impedance also given, which is we name it as Z5 lah, Z5 untuk shunt branch lah. Okay, shunt branch impedance, which is RC plus JXM, 6.32 plus J 43.7 ohms. Okay, this is viewed from the low voltage side. Okay, so this is the shunt impedance Z5. Okay, what we're going to do is to draw the equivalent circuit. The first one refer to the primary side, high voltage side. Okay. So we will just need to use this formula for the impedance calculation. If we want to refer side-by-side impedance, primary to secondary or the other way around, we can just use this equation. Okay, so we can just use this equation that involve the turns ratio. So given that the turns ratio A here, A is 10, right? 10 times. So turns ratio will be 100 lah. Turns ratio is 10, okay? So A square is 100. So we will start one by one calculating the impedances. So given in the question that ZL1, this one is already referred to the high voltage side. Already referred to high voltage side. How about ZL2? ZL2 yang ni ya. Yang ni in low voltage side. So we are going to calculate the ZL prime lah, ZL2 prime, ZL2 prime. Because in this question we are going to draw the equivalence circuit referring to the high voltage side. Okay, so ZL2 prime, simply use the formula A square ZL2. Okay, so just write down the formula and substitute the value, which is 10 square ini saya padam balik . Saya tak tulis unit dia ohm lah. Okay, next leakage impedance atau shunt branch, shunt impedance. So shunt impedance seen, dia kata seen from the given shunt impedance seen from low voltage side. So we also need to transfer. We also need to transform into Z phi prime lah. So Z phi is at the seen from the secondary side. So we need to transform it to Z phi prime. Okay, which is A square Z phi. Substitute all the values. J 43.7 ohms. Untuk yang ZL2 tadi, ZL2 prime tu berapa? 10 kali ganda 100 0.7 kan? 0.7 100 darab J009 0.9 ohms. Untuk yang ni pula Z phi prime ini 632. Tarik calculation saja, tekan calculator. 4370 ohms. Okay, then next step is just draw the equivalent circuit that we have all the impedances referred to the primary side. All the impedance has already been transferred or referred to the primary side. This is low voltage side. So impedance, everything goes to the primary high voltage side. Okay, so this is ZL1. ZL1 sama je. Saya nak kena tulis guna ni lah. So yang ni represent the ZL1 which is already at the primary side lah. Ini patutnya, okay. Ini patutnya different color lah. Okay, RC plus XN kan. So saya guna color yang merah. Yang ni sudah di-referkan. So this is Z5 prime. Okay, Z5 prime value dia yang ni lah. Kalau awak nak tulis pun tulis ya. Kalau ni sebenarnya dah faham kan. Ni ZL1 yang tadi given in the question. So ZL2 prime yang sebelah sini sebenarnya jadi ZL2 prime lah. So yang ni ZL2 prime. Okay. Right. So that is the equivalent circuit lah. Saya tak tukar value tu. So basically you can just tukar lah the values given. You can just substitute all the values given, which is for the turns ratio here, this one is 10, this one is 1. So we can say that values of impedances refer to HV, high voltage side, is greater by a factor A square. Ataupun dalam kes ni, A square tu ada 10 kuasa 2 ataupun 100 kali ganda lah. And vice versa. Okay. That's it. So we are going to continue answering B. For equivalent circuit, refer to low voltage side. Okay, equivalent circuit refer to low voltage side now. So we do the same thing that we have done in A. Here we have ZL1 need to be referred to the secondary side because ZL1 sahaja yang diberi dalam soalan itu berada refer to the primary side. So we just need to let's say we have ZL1 need to be referred to low voltage side. So if you want to refer ZL1 to low voltage side, we can use the formula to find the ZL1 prime. Okay, so this formula lah, sama saja. So ratio dia 10 kepada, okay, ni A square, 10 kepada 1 kepada 100 lah sekali ni . So 1 over A square is 1 over 100. So 1 over 100 is 0.01. So ZL1 Sekejap ah. ZL1 dia bagi berapa tadi? 0.72 plus 0.92. Okey. Yang ni ya. ZL1 0.72 plus J 0.92. Kita nak refer kepada low voltage side. So, bila kita nak refer kepada low voltage side, maksudnya kita nak dapatkan ZL1 prime lah. ZL1 prime. Bila kita nak refer kepada low voltage side, ZL1 prime, dia gandaan dia mengurang sebanyak 1/100. Okay. So, just use this 0.72 tambah J 0.92. Substitute saja the values. So ZL1 prime tu actually refer to the low voltage side. ZL2, this one already referred to the low voltage side given in the question. ZL2 and Z5 already referred to low voltage side. So there is a need for us to do more calculation of transformation lah. Right? So we just need to substitute directly. So how does the equivalent circuit looks like? Okay, I'm going to draw the equivalent circuit now. When we refer everything to the secondary side or to the low voltage side, you can just draw all the impedances, which is basically the leakage impedances. Kita ada 7 minit je lagi. Saya nak selesaikan ini dulu. So, excitation branch. Okay. So, yang ni kekal. Z5 already referred to the low voltage side. Then it is given in the question as 6.32 plus J 43.7. Then for ZL1, also ZL1 tu lah kita dah transform tadi ZL1 prime 0.0072 plus J saya kena shiftkan sikit dia ni. Dia kacau bahagian orang Dia kacau bahagian orang. Oops, kenapa jadi macam tu Okay. Kau pergi sebelah ni sikit. Kacau bahagian orang. Then tulis saja ZL2 ini ZL2 ZL2 given in the question. Semua unit ohm lah. Okay, so that is the equivalent circuit referred to the low voltage side. So senang saja soalan yang kedua ni. Just use satu formula saja, dan kita dapat all of the equivalent circuits asked in the question. So I'm going to continue tutorial 2.5, but your class has already been you'll still have some 5 minutes. So saya nak start recording yang ini.